Welcome back to GR3 YouTube channel. Okay, technically speaking, this is part 2 of this rebuild procedure, but the first video failed and became a major problem. It showed the demise of this rotator controller. That was basically, I think it was lightning struck. There was a lot of problems. Transformer was blown up. Motors, the destroyed drive motor was blown up. PC board was blown up. It was just a major wreck. The same thing applies to the actual the rotator itself, which I'll show in a later video. Hopefully I've got that still, but we had a few problems. So basically this is technically part 2. So basically I've stripped the whole thing down. As you can see, the casings have been repainted because they were quite bad. This is a later model one, the longer version. So I've actually cleaned these up and repainted them, the top and the bottom casings. I normally like a cream colour. I couldn't get that cream colour. They can do what I've got. So in the big scheme of things, I'm building this controller up to suit the rotator that it will be driving. So I'm going to be building up a 24 volt DC rotator, and basically because I'm using what I've got. So basically I'm just going to do a quick run through on the upgrades and repairs I've done to this particular controller, and then later on we'll get on to the mods and upgrades of the actual rotator itself. So first things first, as you see, I've actually done the casings. I've also put in an IEC socket into this. So we have an IEC socket, earth bolt comes through the bottom. So I've done a few little upgrades on this in a few ways. We have now oh, let's show this. The replacement PCB will be one of the ones I have had made up. It's the DS7R board. This is a remote control board. It can be configured to do AC or DC controllers. So we're having that. This is the DC version. This is one of the versions of the DC one. This one has a remote power supply. Normally the power supply is sitting in here. So we'll put that back into here. The power supply now is remote. So it's just a little board, bridge rectifier capacitor, which then feeds into a PWM speed controller. Because we have on the front of the, if you didn't know, the front of these standard controllers have a speed control, and they're an AC rotator, so pulse indicator style. So basically I have put the pot for this 10 amp, say the size, it's 10 amp this one. So I'll put the pot under here, and basically that's what we're doing, that's what we're going to be doing. So the PWM will be going in, and that will be mounted on top of the transformer, which I'll get to you in a second. So we'll go over here. The transformer I got here is one that I had for an imitator rotator, which is basically what these boards are emulated on. So basically this will be sitting on top of here. I'll be sitting under these little screws down here, so it'll be mounted on top of the transformer. So this is has all the wiring necessary for controlling that board. So basically it's a Australian made transformer by, if we can read it there, zoom in, Star Delta, which is not far from me. Multiple outputs. So we have had 21, 0, 21. I've actually taken one of the 21s off, one of the white ones down the bottom here. Not needed because I'm only running a single one into the power supply and into that. We're not running center tapping. And then we have 8 and 12 volts, which everything was needed on that board there. So Australian made transformer. This is a 72 VA at all these voltages. So basically, okie dokie. Okay, so since there was a lot of destruction in this, I've had to replace the display drive motor, and I got this at a local shop. It looks pretty long, but it's and big and everything, so all I do was make up a new mounting bracket for it. Just happens to be a broken gear from the drive of one of the CREATE rotators. I just had to cut it down and clean it up. So basically, so this is a 12 volt motor with a gear head on it, and I just had to change the shaft size into the drive gear for the needle. So that's all sort of ready to go. As you may notice, there is a mount at the back corner. This PC board sits in there like that, and it's held in place at the front by another one of these little stand posts, standoff posts, and that sits in. Whoops, let me get it in the right position. I'll put the board down. I need more hands, not enough hands at the present moment. That just mounts in there like that. A screw comes from the bottom, and these actually have, both of these have actually got they're plastic, but these have been threaded, and they've got an M3 recoil insert inside it. So basically that's what's going on there. I've got the coughs today, sorry about this. So, trying to get forward, get done as much as I can while I'm surviving with this coughing going on. So, direction display will still be the same switch, power switch will be the same. I'm still using the original speed control knob. I may replace this terminal block to the back. We'll see how we go with that. And we're now going to what I've done for the display. Since we need to have, with this PC board, we need to have a 500 ohm potentiometer. I've put a 500 ohm potentiometer into here. I've also put a little baby PC board in here, which is all it has is just the IDC terminal block out to fit wherever he's gone to. There it is. This will just pop under here, so that's make things easier to get on and off. Now we're remoted to the board, which goes off one of these terminals on this side on this hubby. So we've got that on there, and I'll take it back off again. And I've also installed LED lights into this, 12 volt ones, since this board, I'll go back over here again, we're jumping around a fair bit here. This is a 12 volt output DC to DC converter. So what comes into this is about 8 volts. So basically it's converting up to 12 and a stable 12 volts. So, which is one of the things that I did with this board. It's one of the last things I did with this board when we added this onto it. So that is controlled. That controls these two LEDs banks. So as you can see, the actual can, or the reflector can, is in actually pretty good condition. The front panel and all the sundries and bits and pieces were in good condition. The casing was in average condition, but there was lightning strikes coming through from the back. There was actually, you can see it arced across on this here, not now, what I showed you before, but that video died. So I didn't get to show you all the damage. It was a bit of a mess. So basically the rebuild is happening. So as you can see here, the little bezel is in good condition. The lens itself is in good condition too. It's in a plastic bag, I'm not going to take it out. It's in good condition. The actual direction display is in good condition as well. Stops flaring out, will be right. So all intents and purposes, it was in reasonable condition, except we had major fires, I suppose you could call it. So where are we? Get the PC board out. In here we have all other sundries like needle, and as you can see, the needle is in pretty good condition. We've got, let me get the light in the right direction. All the screws and bits and pieces are in this here. You want to get them all out, they go everywhere. So basically that's where we're up to with this. So I will move forward. I'll start assembling everything to get things moving forward with this particular rebuild. I think I've probably mentioned I'm not going to be using all the outputs, but this will be used. I will be using the remote output for this one. I won't be using that. There'll be a little sticker going over that, and there'll be a sticker going over this direction, a switch, because when the Creates have remote control of their P versions, you've got to switch it between remote or manual operation. So basically, yeah, I also did, as I put an earth bolt on here as well. Earth bolt. So I'll put all the bits and pieces in here. The power supply will be going there. Power supply will be sitting on those screws there. And it has a 4-pole terminal coming out of it to go to the board, well, in and out. And probably mentioned this before, I've actually got a hole in the earth tag, and the actual earth bolt, or an earth bolt, comes through from the bottom, and this will eventually go into there, and looks the other way around, and be bolted to there. So there we go, that's how we're getting all the earth. And another thing I did too, I actually stabilised the back here a bit more by putting a little baby L bracket on here. We can't see it that well, just go straight through, a little baby L bracket, just to stabilise the back of this. The PC board itself has rubber feet to keep it off the wall or the side of the casing, and when you sit in there, it's hard up against the back, and it's hard up against the front when it's all in there and done. And then I just got to do all the wiring and all this stuff, so it's a fair bit to be done yet. So we shall move forward, and I'll just stitch a whole lot of little videos together to show the progress of the rebuild of this. Basically, this controller was basically stuffed. So the rebuild continues. Okay, we shall move forward. Catch ya. Okay, we're back. Righty-righty. Where are we up to? Okay, number one, I have now installed the AEC socket and its little earth bolt, which comes through from the bottom, as I mentioned before. I've also installed, which I need in this one, with this PCB, I need to have a meter adjust, so that's in there. I've actually installed a replacement terminal barrier. This one just happens to have some bloody tooth washers on the back of the screws, so I decided to do that. I've got the remote in, as you can see, and I've actually labelled this so we get the light in the right direction. So that's all in there. So you know, we've got the remote socket in, that's already wired up with these neat little push terminals, which are push wire terminals. You terminate them by pushing the wire in, and then I actually glue them in position so that they can't go nowhere. So that's that. What else have I done? Well, let's bring the transformer over. The transformer now has the PWM speed controller on the top of it. So that's now done. Oh, I forgot to mention, that's right. I've also installed self-clinching nuts into the 4 mounting points. I forgot to mention it before. Down in there. So now we don't have to trying to get nuts in there when we're putting it into the bottom, because that will just mount onto these 4 holes, and we just screw it up straight from the bottom, so we don't have to worry about trying to put nuts on and all this sort of stuff. So yeah, that's another thing that I've done. Motor has been installed, and I probably did mention before that I made that little bracket for it, so that's now installed. I've actually done some testing to make sure this rotates at the same direction as previous motors, so we know where we're going. So it's all been, gears have been meshed up, pots have been aligned in a sense, so that's all moving forward. And that's what we'll be doing next. We'll be proceeding with the assembly of this thing, and then I can actually get onto the rotator. So okay, so I shall carry on, and I shall be back. Back for a quick one. I forgot to mention, I've actually put a 3-legged terminal directly onto the direction switch, because this one, it utilizes switching earth. So basically that will just plug into here, so we can actually remove the front panel if we need to work on it. I like to make things easier for working on, so basically this will just plug straight in. As you can see, we'll just plug straight in like that, presto, and you can pull it out. Coughing, sorry about that. So yeah, I've got all my little directions on here saying which one's left and which one's right, because this one goes the opposite way because it's switching across the gate. So basically, yeah, and this is a locking direction switch, so in this particular one. So basically that's that little quick update. We shall now carry on. Okay, we're back. Righty-o, let's see where we're up to. I got a bit carried away. I started on the wiring, and basically one thing led to another thing. So now I have the PC board installed. Most of the wiring is done. So as you can see here, we're spinning them around. So the only thing that's not done is, since this replacement rotator, and this is a different board, these two wires which go to the direction for the motor, so I won't know which way is left and right until I physically get the rotator done. So these are remaining loose at the present moment. So basically that's all done. I have actually wired in. So what I basically have done is I've got the direction to the motor here, I have limit return here, and pot reference in these three here. So basically, yeah, so it's, and I've also I'll explain more about the limit return, but this is the other end of the limit return for the limit light, and we have, I've got these are just plugs, so it makes it easy to physically take the front panel off. You know, so basically I want to try and make this thing as easy as possible to work on. So basically that's all up to that stage. So now the front panel, which is now totally off, I've actually got that together. I've actually got a little sticker in there now too. So now we have a 3-pin plug I can just plug straight in. We have here, we have the limit light, which is that one there. Underneath the actual, there it is, limit light, which I'll be wiring in, and that's just going to sit here. So I decided to, I was going to make this fixed, and I decided, well, if I need to get the front panel off, this panel off, in other words under those 4 screws, I need to be able to make this come out as well. So basically I've made it just a clip version, so the actual terminal just slides on, then we just slip it on into the actual clip here, as you saw before. The display illumination is put in by those ones there, so I want to make that removable easily as well. And I've got the potentiometer wired. That may change, but yeah, I'll probably try and wire the other end, I think, at the rotator end. And I've also got the speed control knob on. This was a new potentiometer, so basically it's a different potentiometer for the PWM. So it's wired up. I've actually got a resistor sitting in under here. This just limits how far I can go back towards 0 volts. I've got it set to about 12 volts at the present moment. So basically, as far as I can turn it back will be 12 volts, so the motor doesn't stall. I may be able to adjust that later on. I might even put a variable on the inside. I don't know, just see what happens. Just have to see. You know, I don't really want to go much slower than 12 on this one. So, you know, we're getting moving forward. Oh, and I've also wired in this second wire goes to, I'll show you that too as well, this second wire at the bottom here with one little plug on it, one little IDC plug on it. That was not I normally soldered onto the potentiometer. So what I've done is I have soldered onto just a single pin onto the wire that goes to it, and I've used some Bondic on it and basically mount it so it can't move. So we actually can just unplug that. So if we want to, when we want to put it in, we just slide it in. We've got to screw that on, plug it in, plug that one air in, and plug these in, and we're ready to go. I probably should have made the the AC pluggable, I may even do that yet. So that's something, the attachment is a bit bloody tight, so I'm still contemplating doing that. So just moving forward. So basically things are getting there. So I'm seriously thinking about putting this on because it's very tight, this, so I might even do a one for that, so it makes it easier to get in and out, so I can actually just plug and plug. So yeah, another thing I did too as well, I've actually painted the screws for the casing in the same colour as the casing. So these are normally like a stainless steel screw. Well, I just painted them so they don't show up as much on the casing there. So all good. I shall be back. Okay, I went and did it. I went and put I've actually forgotten I had these little I think they're little baby, although they look like Molex, but I've actually used this for the power cord. I've actually sealed the back of these up so they can't move around. So, and I've put a little short lead onto the plug, onto the actual switch I should say, and I've put the plug onto there. So it makes it easy when the clip's on this side than other than on that side. I wasn't going to put that side, but it makes it harder to get off. You can actually just clip it on, clip it off. So basically that is all done now. I can now move forward and get things hopefully finalised soon. I'll be back.